Our class today, we're going to look at local max and local min, which is also called relative max or relative min, and how to find them and how to use calculus to do it. So local max and local mins always occur at critical points. Not all critical points are local max and local min, but all local maxes and local min come from critical points. A critical point is where the first derivative is 0 or where the first derivative is undefined. Okay, those are all your critical points. So to find critical points that could possibly be local maxes and local mins, you take the derivative. So if I take the derivative of this function, I get y prime equals 8x cubed minus 6x. Set that derivative equal to 0. I can factor out a 2x from both of these terms. I get 2x times 4x squared minus 3 equals 0. Zero factor property says either 2x is equal to 0 or 4x squared minus 3 equals 0 or both. If 2x is 0, I can divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. 0 divided by 2 is 0. I get x equals 0. 4x squared minus 3 equals 0. I add 3 to both sides. I get 4x squared equals positive 3. Divide both sides by 4. 4 divided by 4 is 1. Times x squared is x squared equals 3/4. Square root both sides. The square root of x squared is the absolute value of x. All right. And the square root of 3/4 is the square root of 3 divided by the square root of 4, which is 2. Notice, a lot of teachers say that the square root of x squared is x. That is not true. The square root of x squared is the absolute value of x. For example, what if I had the square root of negative 2 squared? By your definition, or by this definition, the answer should be negative 2. Because my x is negative 2. Square root of x squared, square root of negative 2 parentheses squared. But the answer is not negative 2, it's positive 2. So this isn't true. Square root of negative 2 squared is the absolute value of negative 2, which is positive 2. Negative 2 squared is 4, and the square root of 4 is positive 2. Okay, so you have to put absolute values when you take the square root of a variable. So absolute value of x equals square root of 3 over 2, which means x can either be positive root 3 over 2 or negative square root of 3 over 2. So that's where your plus and minuses come from. They don't just magically appear. They come from the absolute value sign that a lot of teachers will skip down to this. Okay, so plus or minus square root of 3 over 2. Let's substitute both those into the original equation. Get some room over here. So notice that the derivative doesn't have any places where it's undefined. It's a nice smooth cubic. No division by 0, no square root of negative numbers. So I don't have to check for undefined. Those are other types of critical points. But I just check where this derivative is equal to 0. And I get 3 values. 0, square root of 3 over 2, and negative square root of 3 over 2. Let's put 0 in the first equation, the original equation. So y of 0 equals 2 times 0 to the 4th minus 3 times 0 squared plus 1, which gives me 1. Y of positive square root of 3 over 2, and I'm going to write it like this, y of 3 to the 1/2 over 2. That is 2 times 3 to the 1/2 over 2 to the 4th minus 3 times 3 to the 1/2 over 2 squared plus 1, which equals, if I take this to the 4th power, power to a power says that's 2 times 3 to the 1/2 to the 4th is 3 to the 4/2, or 3 squared, which is 9 on top. 2 to the 4th is 16. 2 times 2 is 4 times 2 is 8 times 2 is 16. I got 16 on the bottom. Minus 3 times 3 to the 1/2 squared is 3 to the 1, which is 3 on the top. 2 squared is 4 on the bottom. And I still have this plus 1. 2 goes into 16 8 times. So I've got 9/8 minus 9/4 plus 1. So that equals 9/8. Multiply 9/4 by 2 over 2, that's minus 18/8. Get a common denominator. 1 is the same as 8/8. So that gives me 9 minus 18, which is negative 9. Negative 9 plus 8 is a negative 1. So negative 1 over 8. Right? Y equals y of negative square root of 3 over 2 gives me the same answer. That is 2 times negative 3 to the 1/2 over 2 to the 4th minus 3 times negative 3 to the 1/2 over 2 squared plus 1. If you take a negative 1 to the 4th power, it's positive. Take this negative 1 in front of the 3 to the square power, it's positive. So I get the exact same answer. I get back to negative 1/8. So, if I put a 0 in, I get a 1. If I put square root of 3 over 2 in, I get negative 1/8. If I put negative square root of 3 over 2 in, I get negative 1/8. Square root of 3 over 2, let's pull it up on the calculator real quick. Square root of 3 divided by 2 is about 0.658. 0.658. Alright. Just double check. 3 square root divided by 2. Oh no, it was, I don't know what I hit fat finger, but it's about 0.866. So positive 0.866, negative 0.866, and down a negative 1/8. So a negative 0.125. And then also 0, 1. Those are places local maxes and local mins could occur. And if I look at Desmos, which I have pulled up, here's the graph, and you can see 0, 1, that's a candidate for local max or local min, happens to be a local max in this case. Over 8.66 down negative 0.125, that's over the square root of 3 over 2 and down negative 1/8. And then to the left, square root of 3 over 2 and down negative 1/8 are other possible local max. Happens to be local min and local min. But if I didn't know the graph and I wanted to find out using calculus if they're maxes or mins, one way to do it is with the second derivative test. The second derivative test says take the second derivative, so if y prime equals 8x cubed minus 6x, the second derivative, y prime prime, is the derivative of 8x cubed, which is 24x squared. Subtract the derivative of 6x, which is derivative of negative 6x, which is negative 6. All right, and I'm going to evaluate that at 0, at root 3 over 2, and at negative root 3 over 2, my 3 critical points. All right. If I evaluate that at 0, I get a negative 6. If I evaluate it at root 3 over 2, I get 24 times root 3 over 2 squared minus 6, which gives me 24 times 3/4 minus 6. 4 goes into 24 6 times. 6 times 3 is 18. 18 minus 6 is 12. If I put a negative square root of 3 over 2 in, 24 times negative square root of 3 over 2 squared minus 6, that's going to give me the same answer because this negative root 3 over 2 squared is the same as positive root 3 over 2 squared. So I get the same answer of 12. All right. I don't really care as much about the number in this case as the sign of the number. This sign is negative. When the second derivative is negative, everywhere the second derivative is negative, the original function has a frown. It's concave down. And everywhere the second derivative is positive, the original function has a smile. Positive smile, negative frown. All right? And where a concave down changes to a concave up, that moment that it changes concavity is called an inflection point. Here's where the second derivative is negative, and then it goes through a 0 second derivative, and then it's positive, a smile. It goes from a frown to a smile through an inflection point. Okay? So, every value of x between here and here give me second derivative of negative numbers. And every value of x from here to here, give me second derivative of positive numbers. All right? So negative second derivative is a concave down or a frown. Positive second derivative is concave up or a smile. All right? So since I evaluated this second derivative at 0, at positive square root of 3 over 2, and at negative square root of 3 over 2, at 0 it gave me a negative answer. So I know 0, which is a possible local max or min, is a local max. Okay, how do I know? I know its slope is 0 and the second derivative is negative. If the slope is 0 and the second derivative is negative, I'm at the top of a mountain. I'm at the top of a mountain. All right, my slope is 0, all right, but my second derivative is negative, which means I'm concave down. That means I must be at the top of a hill. I'm at a local max. So here's what you say. Local max occurs at x equals 0 with a value of f of 0 equals 1. Because, or in this case, y of 0. Let's keep our variables right. Y of 0 equals 1. Because y of 0 is 1, and I showed that at 0, the first derivative is 0, which means it is a local max where I'm in. And the second derivative is negative at 0, which means it's a local max. I'm on the top of a hill. Have a 0 slope on the top of a hill because I'm concave down. All right. Square root of 3 over 2 and negative square root of 3 over 2 are both local mins. They are positive, which means they're both smiling. And I'm at the bottom with a slope of 0 at both those smiles. So they are local mins. Local min occurs at x equal to plus or minus square root of 3 over 2 with a value of negative 1/8. It's a tie. And if we look at Desmos, you'll see over 0 and up 1 is a local max, and to the left, square root of 3 over 2, comma, negative 1/8, and to the right, square root of 3 over 2, comma, negative 1/8. Those are my local mins. So let's look at Desmos. Yes. 0, 1 is a local max. I'm at the top of a hill locally. And to the left, square root of 3 over 2, down 1/8, and to the right, square root of 3 over 2 and down 1/8 are my two relative mins or local mins. All right. We'll talk more tomorrow about global max and global min, but this is enough for now.